Alright, automatic control and practice, principles in practice 7, electric components. A rather large number of the components are able to convert with the magnitude of a control variable into an electronic signal. Input signals to the components of the EMF, the thermocoupling, or pH electrode, or resistant change of a resistant temperature detector, a strain gauge, etc. These signals are applied with the amplifier, its circuit, or to a galvanometer, diaphragms and bellows over the infrequently input signal systems, which are combined into a variety of electronic components to convert the mechanical into electrical signals. Figure 7 and 1 show the most common of these components, thereby with no means only one of the most frequently found of the control system. Following pages describe the components are listed in this illustration. Pedometers consist essentially of a sliding contact, slide wire, and a slide wire. The sliding contact is mechanically positioned generally by a rotary. It shows diaphragm going into pedometer, capacitor, inductance, differential transformer, thermocouplers, the amplifier, electric, magnetics, galvanic. But sometimes translational motion. This device is obtained with also convert with the mechanical position into the electrical signal. Figure 7 and 2 show the general arrangement of supply voltage E minor subscript S is kept constant. So E voltage is supply, pedometer, and E load. Load is subscript L, varied means of the sliding contact with equation expressed as load voltages. Load voltage is defined as sliding contact times resistance load times divided by position slide contact times resistance of pedometer plus resistance of load minus the position of slide contact squared times the resistance of the pedometer times the voltage load supply. Alright, where K defined with the position of sliding contact, R subscript L is resistance of the load, R subscript P is resistance of pedometer over the slide wire. If also slide wire or resistance pedometer is parallel with load resistance L, then K is equal to 1 and is only 1/2 of the parallel of the position of sliding contact is 1/2, etc. Equation show the anomaly over the relation between the load of the supply voltage, however, the making of the resistance load with the largely compared with the resistant pedometer. Equation approaches the linear relations of the energy load equal to the position of sliding point, sliding contact times energy supply. Linear behavior of the pedometer circuit differs from that of the pedometer such. Later refined with the relation of the sliding contact position resistance between sliding contact and slide wire terminals. As a rule, the linear is specified with the normal independent linearity. Alright, the resolution sensitivity of the pedometer is largely determined by the fact of the sliding contact path from one slide wire to the next. The wire length of the term represents a certain magnitude of the resistance width that is covered by the slide wire in one single step. Thus, the resistance change of the step rather than continuously the finer the wire, the more returns and the smaller the step. But at the same time, the finer wire represents a larger resistance. Actual change in M of the resistance about the same. The base way to improve the resolution sensitivity is increase the sliding contact travel. If the travel is rotary, then an increase of the radius will be given the best results. Multiple term pedometers provide enough of the method to increase the resolution sensitivity. Either case of the travel to increase the resistance per turn is in decrease. The total of the resistance pedometer remains the same but the resolution sensitivity improved. This is variant stepwise response is overcome by even a single straight wire with the result of the term of the resistance, which are too low to be practical. The wire may be replaced by conducting films of high resistance and can be expected with the conducting plastics will feature widening the considerable of the useful of the pedometers for the control system. Resolution sensitivity of the pedometer depends further on the static friction between the sliding contact and the wire with the bearing of the shaft of the carry with the sliding contact. Certain minimum torque on the shaft has to be developed before sliding with the contact is loosened from the holes of the friction. Frequently, the resolution sensitivity of the pedometer is specified, but the resolution refers only to the stepwise of the arrangement of the windings, not to the friction effects. Contact between the sliding wire constitutes itself with the resistance produced the film and develop the oxidation or other causes of the metallic surfaces. causes local heating and a heating of the frequently cleansing effect, although it may even worse for the condition of the metallic surface as a result of the minute changes. Overall resistance may be harmful to the total effect of the control circuit. The vibration caused by the contact pressure of the vary may have a similar effect with a number of the other causes may produce the spurious changes in resistance resulting in the phenomenon is termed noise. Most disadvantages of the pottometer are due to the physical contact between sliding contact and slide wire, which produce the friction in the wear. Precision pottometer has a life expectancy of about 1 million cycles, considerably that in the control system, a sliding contact may easily move an average of 4 times per minute. This motion may concentrate the limited portion of slide wire of the life expectancy, such as pottometer would be only 1/2 of the year. This leads to the conclusion that pottometer should only be used wherever the sliding contact moves, not more than occasionally, but the non-contact device offers greater disadvantage of all other applications. Alright, pottometers and rheostats. Figure 7.3 illustrates the difference between pottometer and rheostat. The pottometer is an adjustable voltage divider, while the rheostat is an adjustable resistor, which regulates current. Frequently, a choice between either one of the two elements has to be made, and the control circuit with the pottometer will generally be preferred. This is energy 1 or energy 2 resistance pottometer, rheostat with a pottometer and a rheostat. Because of the accuracy of the output-input relationship with the pottometer is determined by the linearity winding resistance of the commercial position. Pottometer is about 0.1%. Commercial tolerance of the total resistance usually plus or minus 5%, but this has no influence overall accuracy of the pottometer. So we have energy 1 over energy 2 is equal to variations in R, which would be the resistance time, the sliding resistance, slide time resistance. Particular importance of the magnitude resistance is affected by temperature variation. Rheostats change with the 5%, with the will change with the current with the same percentage. Further point to consider: the pottometer is connected to the cutoff of the power source for the energy through the load is open. Therefore, the remaining shunt through the pottometer, in this case the rheostat, the power supply is left in with an open circuit with the load is removed. Capacitors. Capacitor is essentially a frictionless device changing the electrical characters of the circuit with the two metallic plates separated by the air with connected into the AC circuit, resulting in a capacity which is expressed as capacity equal to infrared equal to A is the minimum square in area of either plate, in which directly opposite of the other plate time divided by 4.5 times D, the distance between the plates in inches, times 10 to the negative 12. For example, the pressure sensitive of the diaphragm can be arranged as effect with the process pressure at the same time constitute one plate with a capacitor over the other plate is fixed. Some of the distance with D is changed with the deflection capacity. It also changes. The current through the electrical circuit is given by I is equal to E time. The current amp is equal to potential voltage time divided by the impedance. The combination of the capacity and reactance is on ohms. Furthermore, your impedance is equal to the resistance square, the square root of resistance time point, the resistance squared plus 1 over 620 frequency cycles per second, and it's in capacity, and then times that squared and the square root of that. So where the frequency in the cycle per second with the R is the resistance of the ohms, also shown in figure 7.4 of AC power source capacity and resistance. And quite obviously the equation can be varied with the substanding number of the capacity has two very large frequencies, very high, and produce current of the reasonable magnitude. Inductance coils. Another resistivity element with electrical circuit with the alternating current is induced with the coil with the alternating current flows through with the coil with the magnitude filled with the produced with the round with the coil with the pulsating and intensity with the direction of the frequency with the current pulsing with the field generated in the EMF with the coil with the opposed of the circuit. This with the counter EMF with effects similar to those of the resistor is of the fact that it determines the inductance. Figure 7.5 shows the circuit which combines the resistance with the inductance for this impedance and the circuit. The impedance is equal to the resistance squared and plus 6.28 times frequency load squared and the square root of that. L is the inductance, L instead of inductance. So, figure 7.5 resistant inductance circuit, you have AC power, inductance, and resistor. Insulated with a wire wound around an iron core, inductance is equal to inductance equal 376 times 10 to the negative 8 times N of the number of terms time with the distance in an inch in the coil within diameter times squared over L, the length of the iron core, where L is the inductance in henries, N is the number of the turns within the coil, D is inside of the diameter coil, inches, L is the length of the iron core in inches. The iron core is removed with the inductance. Inductance equal to 2.5 times 10 to the 8 times the number of terms squared times the distance in inches in the coil and inches squared divided by the length of the iron core. In other words, when the induction changes about 150 times when the iron core is introduced. Since the iron core can be moved in a coil without physical contact with the inductance, with the impedance in the circle can be changed without friction. Differential transformer inductance are described above with the self-inductance of a circuit equal to the moment where the two coils of each belong with another circuit of the probes of the closer together with the mutual inductance result of this is the principle of any transformer. Alternating current with the primary winding produced with the magnetic field within the vicinity of the primary with the changes of the intensity of the direction of the frequency and of the alternating current. Flux line of the magnitude field cut with the windings of the secondary coil with induced of the EMF and the secondary magnitude of multiple mutual inductance expressed in Henry and self-inductance. The mathematical relationships are also the same difference between iron core and air core, similarly pronounced. The difference of the transformer effect of the iron core because of the further intensified because of the secondary is split in two different coils which are arranged in various ways. One typical arrangement illustrated in figure 7-6. Two secondary windings are connected in such a way that these polarities buck each other with a given moment into the position shown with the iron core central position due to the bucking effect of the resulting EMF in secondary zero as the core. So here's the primary and secondary core differential transformer. You have capital A, minor K, and that shows winding. Or displace upward with the EMF of the upper winding increase simultaneously with increased lower winding with the result of the output of the equal with the difference between the EMF induced for the upper and lower with the windings place shifted between the secondary and primary caused by magnetic circuit. Discarding the phase shift of the polarity would be such that for any given instant of the current over the A wire of the primary has the minus polarity of the current over the A of the wire of the secondary within plus. If the core display for the downward output is output is equal to the difference between the EMF induced lower and upper winding, but the phase is not reversed, which means that they are given an instant with when the polarity A minor A wire is minus the polarity of the bigger A wire is. Plus, the additional phase shift between secondary and primary does not alter the basic phase of the reversal characteristics described. Differential transformer has perfect resolution since within or linearity is ordered with the 5/10 of the percent with the maximum output over the specified stroke. Power of the output is low due largely with the imperfect coupling between the primary and secondary. Two, with the restriction side with the generally imposed with the design. The differential transformer understand with the output of the differential transformer requires amplification to be utilized with the control applications. Galvanometer. The phenomenon of the magnetic field established for the alternating current flowing through the coil has been discovered in inductance coils. If the alternating coil is replaced with a direct current with the magnetic field still exists, however, it does not pulsate with no counter EMF to produce the current flow through the coil is determined only by magnetic resistance. The steady of the magnetic field has a north and a south of the pole. The intensity of the magnetic field with the function of the magnitude of the current flowing from through the coil. The coil is free to move with the coil and it orients itself with respect to any other magnetic field that surrounds it is equal to the equal pole. The repel unequal poles attract each other. It is seen in figure 7-7. A small cylindrical air gap is left in the magnet circuit, which is established phenomenon. Permanent magnet with a pole pierces. So shows your galvanometer. You got your pointer, permanent magnet, hairspring, movable coil pole pieces. A stationary coil with the DC current flows through with a movable coil with the magnetic field with the interact with the flex core permanent magnet, resulting in torque of the coil restrained by a hairspring. The magnitude of the current flowing through the coil determines the deflection. Torque of the galvanometer is comparatively small, with the motion over the pointer has to be picked up by other devices. Mechanism would be perfectly and periodically feel with the position of the relay with the position into a more powerful action that has been used for many years, but are no more being gradually abandoned in favor of vanes mounted on the pointer, moving them between the oscillation coil with the interfering between the light source and phototube. Oscillators. The principle of mutual inductance employed with not only with the difference of the differential transformer, but also with the oscillator. Figure 7-8 show the typical the resistance capacitor 1. You have a grid circuit. You have load 1, load 2 plate circuit, relay. Capacitor 1, 2, resistor R, load 1, load 2, or inductance winding 1 and 2, relay, and I believe that will be the oscillator single on a transistor. Oscillator control servo the plate, servo the network with a combination pen with the L2 and relay current capacitance CC1 in series. Power supply with the plate cathode over the tube with the grid circuit with the combined with the capacitor 2 with the independence of the L1 resistor and the resistor R with HR in series with the grid over the and plate over the tube. Oscillation is produced by the plate with the grid circuit with the coupled with the impedance 1 and 2, as long as the coupling perceive the current with which will flow with the keep the relay and relay energized with the metal vein is inserted with the between the impedance of the vein acts as shield with a magnetic field with a disturbing mutual inductance. Result is that the current flow is interrupted with and the relay de-energizes. Combination of the inductance 2 and the capacitance 1, so-called the tank circuit with its capacitor travel with no plate current through the capacitor discharge into the inductance. Current flow induces a counter EMF in the inductance of the discharge into the capacitance. In this case, the power indicated with the capacitance with the current pulsation could continue indefinitely. So, however, the sum of the resistance always presents a magnitude of the circulating current will rapidly decay unless the plate current begins to flow and supply with new energy. When the vein prevents the mutual inductance of the grid will negatively charge because of the action of the grid bias of the circuit consisting of the resistor and the capacitor 2. If the principle of the grid control tube with the negative grid prevents flow of the current in plate circuit with expecting with the circulate current between capacitor 1 and inductor 2, the grid bias of the circuit is also contributed to limiting of the amplitude will be shown. If the vein removed every minute of the current flowing through inductor 2 with induced some voltage in inductor 1, polarity of the voltage and such that it makes the grid less negative, the result of the more current flowing through with the inductor 2 and more induced voltage in inductor 1, making the grid bias more positive than increase the current through with the inductor 2, etc. The action clearly feedback with the action power with the negative feedback. The circuit is more purposely made unstable to have the instability of the and the amplitude of the oscillation is controlled with largely due to the grid bias of the network supply with the voltage of the inductor 1 is large enough to make with the grid bias voltage positive part of the cycle with the result of not only with the increase of the length curve of the produce the considerable grid current. This is the capacitor 2 of the grid becomes negative again, and the capacitor 2 discharge through with the resistor with the consequence of the grid becomes more negative than it would be without a capacitor with the means of the more position positive the grid may have with the one moment, the more negative will be with the next moment the limit of the plate current, hence the amplitude of the oscillation. Oscillator circuit may also be designed to the frequency rather than the amplitude of the oscillation changes with the free change of the induction of the principle is due for the Bristol controller. Oscillators have the advantage of high sensitivity vein motion of 2,000 of an inch suffice for the change of the oscillation of the current of the circuit through enough of the de-energized relay. Since it's difficult to transmit higher frequency over an appreciable distance, therefore, with the necessary with the build with a moving element with a vein and complete with the oscillator with a single unit phototubes. Ordinary vacuum tubes emit with electron with a cathode with the heat with the resulting flow with electrons equivalent to electrical circuit current with a tube with the plate current with the phototube. The difference insofar with the cathodic does not need to be heated by light sent with the red, but hence heat sensitive its current through the phototube. It depends on the voltage across it, light intensity, and also the light color. There are three types of phototubes, namely vacuum, gas filled with a photo multiplier tube, the current which passes through a vacuum phototube at given the voltage potential directly proportional to the light intensity with the gas filled phototube. The relation between the current and light intensity with the nonlinear with the gas filled with the phototube, with however the advantage of the more change with the current per unit change the light intensity. Both tubes generally have an upper limit of 20 microamps. The photo multiplier tube usually rated with a maximum current of 20 milliamps and 1,000 times more than other types of the linear, and the characteristics that have more change with the current per unit change with the light intensity than any other photo tube. Gas-filled and vacuum tubes, however, are frequently preferred because they have lower cost per set with the vacuum tube with greatly stable than any other. Figure 7-9 show the typical circuit with the phototube with the connect with the grid circuit with the triode with the grid with the show with the phototube, the resistor 1 battery, electrical C, electrical voltage C, phototube circuit, relay, battery, relay, tripwire, winding. Alright, assuming this is with the current flowing with the resistor, then the same with the flow for the phototube with the result of the voltage, drop of the current with the resistor with the polarity opposed with the voltage C. The example of the phototube with the current with the 10 microamp with the resistance of the R at 200 million ohms. Resulting voltage drop is voltage times amps times the resistance is 20 volts of the voltage 45 volts. The grid voltage is of the AC is equal to 20 minus 4.5 is equal to negative 25 volts. The current through the photo tube determined over the light. Intensity of the current through the drive over the relay coil depends only on the grid voltage. Hence, the current through the relay becomes a function of the light impinging on the photo of synchros. There are different synchro components of the synchro transmitter, of the synchro receiver, the synchro of the current transformer, and the accessory of the which of the combined with the control of the and vary the ways and found on the pages. The most important and synchronizing components are described in typical combinations shown the synchro transmitter. The principle of the synchro transmitter is that any of the transformer, the alternating current of the primary winding result in magnetic field of the vicinity of the primary with which change the intensity direction of the frequency of the alternating current of the second winding with display for the same magnetic field of voltage induced with the secondary and a current which flow through the load connected to it. Result of the electromagnetic and produced the alternative of the building up of the decaying with the magnetic field of the primary and secondary can be moved with respect to each other, then the maximum voltage induced when the secondary is located over the maximum flux with the primary passes through the winding depending on the direction of the flux lines resulting in the secondary polarity with the voltage. The secondary will either be one direction or the another. Primary synchro transmitter is wound over the rotor while the secondary is distributed with the three separate windings within a stator. This illustrated in figure 7 to 10 depending on the position of the rotor are more open. So the synchro transmitter show the rotor and then they're winding 3 windings 150 cycles and plus or minus negative. Less magnetic flux lines will cover any one of the 3 windings within this position, which for the known with the 0 position voltage within the windings A and C that are equal in same direction, and hence the voltage between the single S1 and S2. Synchro 1 and Synchro 3 is 0. The voltage induced in B with the opposite polarity with either winding A or C with this given a moment with the terminal synchro S2 with the positive with the polarity with the inductor indicated with the figure 7 to 10 while at the same time when the polarity is the synchro 1 as well as synchro 3 are negatively expanding with the decaying magnetic field of the polarity is reversed as shown by the AC voltmeter with the voltage will be continually indicated between the synchro 1, synchro 2 as well between the terminal synchro 3 and synchro 2, but not between synchro 3 and synchro 1. Rotating primary winding will change the condition gradually since the numbers of the direction flux lines will cut through the secondary windings are. All through result illustrated in figure 7 and 11 each rotor position has. Show the output voltage, rotor position, and voltage in synchro 2 and 3, synchros 3 and 1, synchros 2 and 1 and 2, degrees of rotor rotation 0 to 100 and percentage maximum volts positive and negative. Corresponding pattern voltage between the secondary one with the after rotating primary 90 degrees from the neutral position of the voltage synchros S3 and S1 basic maximum obtainable in any position synchro receiver. The most basic synchro arrangement may be considered the combination of the synchro transmitter with the synchro receiver, the secondary voltage with the synchro transmitter that's applied with the second stage windings of the secondary synchro receiver that's shown in figure 7 to 12, essentially with the receiver the chain production and instruction transmitter. However, the input signal with the transmitter is shaft with the position of the output with the corresponding voltage for the input shaft with the receiver. There is the voltage output of its position. Stator windings are of the receiver they're set up with a magnetic field with which the rotor, which itself is magnetized because of the windings are acts like a little needle over the compass, pattern over the field with the receiver, the valve of the position with the rotor, the transmitter, hence for the receiver, the rotor, with the width of the shaft, with the pre-produced, with continually the position, synchro transmitter shaft with the power, which is available at the receiver, the shaft, with the small with the device, with the best of the position to the needle of an indicator. Or show the schematic drawing of synchro transmitter and receiver. Synchro receiver, the synchro transmitter, you have 3 theory wire winds and 150 cycle, and you have your little transformer induction wheel on the side. Synchro controller transformer. After the closed loop of the control purpose of the synchro receiver is replaced with the synchro control transformer with the control transformer, or it is of the essential same construction, either a transmitter or a receiver. The main difference with the rotor shape of the round with the vent with the magnetic field for producing a torque on the rotor. The only electrical power connected with the control of the transformer is the single voltage from the transmitter applied with the rotor with the winding with the stairs windings, the representative of the secondary and with the transformer. Voltage due to the secondary depends on the position of the rotor respect with the magnetic field with the field with the correspond with the 0 position transmitter. The voltage induced with the secondary with the control transformer will be 0 when the transformer rotor is displayed with 90 degrees from the transformer rotor. The 90 degrees of displacement applied with any of the position of the rotor and the synchro transmitter. Sync with the differential of the transmitter with the bi-ranging of the rotor, so that the canaries 3 different windings of the distributor like those of the save of the synchro differential transmitter is connected between the transmitter and control transformer. The save of the winding receive the signal from the transmitter. The output is modified with the position of the rotor of the synchro differential transformer. Puts out the signal which if it's sum of the shaft position of the synchro transmitter with the synchro of the differential transmitter. Combination synchro of the control system. Figure 712 show with the typical arrangement. Synchro of the control variable position with the rotor of the synchro transmitter with the output of the transmitter with the connector of the synchro differential transmitter, whichever where the set point is, and crank with the position of the rotor with the result of the actuating signal, and show the 7-3 synchronizing control variable shaft synchro transmitter with the end to the synchro differential transmitter, which off the set point shaft position synchro control transformer to the amplifier servo motor control output system, and then from servo motor back to synchro control transfer. Amplified synchro control transfer with the rotor, which for the normally position of the output with the amplifier is 0 with the however will deviate from 0 with the actuating signal change with this signal with the amplifier with the train with the servo motor with the device when the will be described further below. Servo motor with the respond with the single by rotation shaft length for the rotor of the synchro control with the transformer with the rotation 0 with the output of synchro control with the transformer that turns the servo to the top motor with the sum in steady state conditions before the obtained within the new position of the servo shaft of the position with which is control of the output signal can be either the position directly with the fine control element or some of the intermediate elements of the slide bar panometer. Other use of the synchro of the above the description do not intend to cover all of the modification amplification. Synchro, for example, the receiver the similar with the differential transmitter that may be built with a triple state with the winding with the permanent plug with the cable as well with the rotor signal the corresponding with the angular displacement of two different shafts the result of the rotor position with a different receiver the proportional of the difference between the angles of the other two shaft positions. Another possibility to obtain with the primary feedback signal of the small angular deviation even the purpose of the synchro transmitter without any of the other synchros. Figure 711 show with a limited deviation from the 0 of the voltage chain with a particular linear within change of an angle. Electronic magnetic amplifiers. Electronic amplifiers with the vacuum tube with the transistors or both with the gas field tube with the therotons are either the output stage when with the required with the output per or succeed with about 25 watts. Transistor over the various form of the transistor point of contact junction etc. Junction transistor is used with the control field with the most frequently typical construction is a positive negative positive transistor illustrated in figure 714 consider the single crystal mode made with the germanium and then some of the other equivalent semiconductor N-type that conducts because the excess of electrons exists and the P-type has electron deficiency and show the base of the emitter with the positive and negative N-type and collectors. A circle of holes with the electron shift that continuously fill up the hole only to produce the hole that leaves the center of the area to constant the base of the area narrow, usually in the order of the 1,000th of an inch for the negative positive negative transistor for the difference from the positive negative positive type and that the base of the positive type of the emitter of the collector both negative type. Transistors have to play with the vacuum tube with the many with the electrons with the advantage of the longer life with expect with the smaller shot with the least heat with the disposition and dissipation. Later with the two character of the usually less of an important with the industrial control system. The disadvantages however the temperature limitation variation character between the transistors the same type of the manufacturer of the voltage restriction. The ambient temperature of 120 to 5 degrees Fahrenheit, usually operating limit with the most transistor with the addition of the output chain with the temperature with the less ambient condition. Be kept constant singular design can be considered the variation voltage of the excess over the above 35 degrees voltage of generally not be able to compare with about 250 volts of the vacuum of the tube with the restricted particular important with the rate over the reset action was provided, particularly always with the resistor with capacitor combination used for this perfect extent with the capacitor recharge that depends on the voltage reduce the voltage of the transistor limits will useful for the resistor capacitor net with therefore a vacuum and will be generally used with the rate with the reset networks. Electronic amplifiers. Figure 715 illustrates the two methods of the U of the amplifier accuracy requirement of the amplifier may depend on the one method of the U of the concave of the A amplifier output must be expressed exactly proportional in input since the otherwise the recorder cannot be provided and show the control variable and the amplifier going to the recorder and also to the amplifier recorder set point positive and negative control variable set point and amplifier null detector faithful reproduction of the control variable the concave of the B however the amplifier with the null detector the output appear with the only one with the control of the variable deviates from the set point with the allowed with the relaxing with the requirement of the linear saturation. The term saturation means for the output signal change with the input signal only with a certain point with the amplifier saturates with the output signal with the remains constant with the input signal change with the beyond the saturation point. Drift and annoy with the character of the wish of the disturbing with the application, for example, the output of the amplifier, show for the derivative of the aging of the power of the temperature, change with the etc. for the voltage, will appear for the wear of the ear, expect with the similar know for the which mean with the spirits, changes in the output due thermal agitation of the molecule circuit components or electrons impinging on the two plates may deviate the amplifier output there from zero. There is generally a preference over the AC or over DC amplifiers because of the later of the greatly tend into the derivative of the DC input signal may be converted into the AC by means of the chopper of the applied with the channel of the AC amplifier. Alright, magnitude amplifier. Magnitude amplifier essential for the DC amplifier, but generally does not have the tendency to drift like with the electron counterpart in itself the far most rugged of all amplifiers, since however even the vacuum tube of the amplifier hardly fragile device higher input cost with the magnitude amplifier frequency most serious handicap. The ability of the magnetic amplifier to convert the small DC voltage with a higher power output with the lead for the application of the temperature control, electric heating furnace with the power input with the heater elements with the furnace directly regulated magnetic amplifier. The DC input is from the thermocouple which measure the control of the variable to figure 7 and 16 show the principle of the magnetic amplifier with the load current supplied with the AC voltage path through the rectifier, the show the DC voltage going and control windings, output windings, rectifier and load, AC supply voltage results, and a current that flows with the load output windings only during the power of the half cycle of the supply voltage of the output winding with the inductance of the load circle with the inductance is stated before the result of the change of the magnetic field. Some of the output windings are wound about with the iron core. This magnetic field of the core controlled with the inductance. Magnetization iron can be increased only by the saturation point. Further, the increase of the current does not change the magnetic field. In other words, the once an iron core is saturated, magnetic field remains the constant, has no more counter EMF induced with the inductance is reduced to the minimum. Magnifier amplifiers designed with the saturation reach with the approximate positive of the peak for the supply voltage, while with the control of signal is zero with the means for the peak of the reach for the inductance as at a maximum, hence only the minimum of the current will flow with it. At the peak with the however the situation change with the inductance vanishes for the current obtained with the maximum value of the voltage peak, however it does not coincide with the low current peak of the inductive circuit. Current lags between the voltage and saturation that occurs before the actual current peak would be obtained. Current flows keeps the core saturated, hence the current will be continued the flow through the remaining half cycle after this current will stop will become the rectifier with the wind with the next spot of the half cycle start with the same sequences outlined above. It is repeated single certain current through the control winding either adds or subtract with the saturation effect for the output winding with the signal is spot with the saturation heads to the current with the flow with the appears before the peak of the supply voltage reach. Time in which the current flow would be shortened by making signals negative with the power with the because of the load current with the peak lags behind when the supply voltage peak. Supplementary signal voltage control of the length of the current pulse through the load of the illustrated figure 7-17 varies. Shows supply voltage, load current, A, B, and C. Time, volt value for the load current during the negative cycle of the supply voltage current does not flow. The pulse with the nature of the magnified amplifier overcoming you for the bridge circle with combining the two cores of the signal unit is shown figure 7-18. If A is 5 and the current B passes through B, and then and C to the low of the back through the D and E with the phase with the reverse of the E becomes positive with the current phases through F and C with the low back through D and G to A. Alright, moving the coil. Figure 7-19 in the schematic representation, moving the coil with the permanent ring magnet is something made over the iron to show the moving oil with the wire connection to the coil with the magnet. Figure AA schematic drive on the moving coil system. Provide with the magnetic flux path indicate with the air of the illustration of the flux path through the air gap wherever the moving the coil is free to move the air with the single current flowing through the coil resist the result of the force of the traction. Propulsion was expressed as force in ounces equal to 9 times 10 to the 9 times B. Magnetic flux density in the air of the gap, then gauge times the length of the wire makes of the coil in inches times the current in milliamperes. The above equality show that even the weak for the current could be made and with the produce of the force increase the flux density of the wire length with the roll of the core for the practical limitation. For example, the 4 milliamperes DC with the common output signal range of the electronic control side with the force of 10 ounces products flux density of the wire length would be magnetic flux density of the air gap times the length of the wire and the MacUp coil in inches is equal to 2.8 times 10 to the 8th. Even with the coil has 5,000 feet, the wire required flux density is still 47 of the gauze considerable the air gap of the 2 inch of the main diameter is a half in height with the required for the cross-sectional area of the Alnico V ring magnet with about 4 square inches. The illustrative of the bulk becomes the limiting factor when the force available to move the coil is considered. Permanent magnet can be replaced by electromagnet. This is the illustrated in figure 720. There are 2 windings, one or more electromagnet moving the current signal coil with the other, then the electromagnet resulting from the proportional multiplied with the current 2 windings of the connection, the shear of the current both of the windings with the chain of the fourth of the proportional square of the current with the important computing element with the obtaining of the application of the mode described in chapter 9. Servo meter figure 721 illustrates the principle of the operation of the 2-phase inductance motor of the interrupter with the iron bar with no electrical connection exists between the rotor and the stationary poles, and winding wires are connected with the 2-phase AC with the electrical power system. The A and B with the connection shear with the 1 phase with the C and the D with the shear with the other phase. Windings are arranged so with the direction current flow with the assume of the illustration there will be North Pole A and South Pole A at South Pole B. Phase of the angle between the phase of the 2-phase system and is 90 degrees with which mean with the current AM phase of the 1 maximum of the current phase 2 with the 0 with the vice versa. As the phase of the power supply proceed with the pole D with the gradually magnetized with it becomes the north pole with which current magnetized and with A decay with the after the pole B will become north and so on. The revolve of the field with established from the iron rod will rotate with it. Alright, if either phase were to cut off, the torque available for the rotor would be correspondingly reduced. Furthermore, motor could not start it by itself. It shows phase 1, phase 2, and it shows your schematic drawing 2-phase inductance motor. Your servo motor is generally with a 2-phase induction motor, so-called with the reference voltage obtained with the directly the line applied with the winding over the A and B with the windings, and C with the D connected with the cross with the control of the voltage varying servo amplifier, control voltage reversible in the phase of either leads or lags the reference voltage by 90 degrees. This is determine the direction of the rotation magnetic over the control voltage depends on the actual single feeding with the servo amplifier with the torque of the servo motor shaft with approximately proportional magnitude of the control voltage. Rotor should be shown in the iron rod, figure 721. The purpose for the illustration complete with the actual servo motor, either the squirrel cave with the solid cylinder with the drive, cup rotor. The important consideration is the rotor lightweight in order to reduce the in-air with the punch if the possible for the permits to obtain the speed rapidly, be easily stopped in reverse. In general, with the servo amplifier will combine the AC and the DC output signal. DC signal is constant with the presence of the even with the AC component is 0 with the keeps of the corresponding pole with the constant polarity providing efficient braking action. Significant difference between the servo motor with the conventional 2-phase induction motor with the later will rotate with the power when power supplied with the servo motor frequently stalled there through the reference windings. Its energy level to produce considerable heating as a result of the servo motor can be used limited power output only at half to 100 watts of the power output with 25 watts or more. A blower is usually needed for the cooling. Small torques from half to 95 ounces an inch and are available to values and can be increased with the gears since the higher rotational speed generally less the requirement of the torque output of the gears. However, the maybe must use the caution since the lack of it can be readily caused with the instability of the entire control system. Alright, torque motors. Restraint with the motion of the servo motor springs allow for the move of the roof with a limited angle only with the torque due to the control voltage equal to the force of the spring motion stops. Thus, angle with the roughly proportional with the control voltage servo motor used in the most form of the call of the torque motor. Another type of the torque motor illustrated in figure 722 for the roof of the designation motor is hardly justified with the devices which is in the show for the magnetic circuit with the coil connection of the torque motor. You have the coil and magnetic circuit stator. Show the coil connections. Consequently, with the torque motor, spring with the restraint with the servo motor with the torque motor is basically a high-speed polarized type of the relay. Coils 1 and 3 illustrations connected with the shear with the one side with the push-pull amplifier. Coils 2 and 4 in series on the other side with the current flowing for these coils with the quiescent current amps IO single current I. When single current 0, magnetic flux, flux 1, 2, 3, and 4 are equal, resulting in the torque of the rotor 0 of the half. The significant current D parts of the 0 of the Z of the coil 1 and 3, subtracted in 2 and 4, vice versa. The case of the flux of 1 and 3 remain about the same, while flux 2 and 4 chain with the magnetic flux in one pair with the diagonally opposite air gaps included the decrease in the other pair producing the torque and spring restraint with the amateur for the resulting torque at a proportional single by obtaining the proportional armature motion must be limited to a very small degree. Comparatively high hysteresis for the torque motors, which amount to 2 or 3% of the generally acceptable control circuit, with somewhat with a more serious consideration differential connections, as illustrated. Commercial electronic controllers do not generally provide with the kind of signal with additional amplifier may therefore be required. Chapter 8, Balancing Computing Circuits.